Welcome to Nature Reserve Roztochya, a protected area spanning 2,084.5 hectares of diverse ecosystems. Established 40 years ago, the reserve is home to rich biodiversity and is managed by a dedicated team of 35 professionals. Over the decades, valuable data about the region's flora and fauna has been recorded in annual nature chronicles. However, this data is fragmented due to varied methodologies. The COVID-19 pandemic and ongoing war in Ukraine have highlighted the urgent need for modern, automated biodiversity monitoring. We aim to ensure consistent, accurate data collection, which is vital for the effective conservation effort.
Це фотопастка, вона має інфрачервоний сенсор тут. І коли встановлюється на дереві, на висоті коліна, умовно кажучи, вона стоїть автономно, доки батарейок вистачає, то переважно півроку-рік, і фотографує всіх савців, які попри неї проходять. Умовно там до відстані 20 метрів. І таким способом ми знаємо, які види савців тут ходять, яка їхня чисельність, плюс-мінус. І використовуємо для моніторингу. Також ми виявляємо порушення. Якщо часом якийсь браконьєр зайде або хтось хоче вкрасти деревину, опаски теж їх фіксують. І ще ми ставимо такі прилади. Це акустичний ресивер. В принципі, середній там чітко цікаво, батарейки, плата, але цей прилад теж в автономному режимі записує звуки. Якщо це фотографує, то це пише звуки. І можна круглодобово протягом тривалого часу моніторити активність птахів або взагалі будь-яких тварин.
As you can see, to address these challenges, we've begun installing camera traps and acoustic recorders across the reserve. This ensures that the entire reserve is now continuously monitored, independent of weather conditions, the knowledge of individual zoologists, or the time of the day. Comparing current data with historical nature chronicles, we can analyze species-specific patterns in detail and even discover new species in the area. For example, the footage shows the Eurasian pygmy owl, a species listed in Ukraine's Red Data Book. Before using acoustic recorders, we had no confirmed data on this species' presence. Now we know it is a well-established species here. These tools also allow us to study daily activity patterns and seasonal phenomena in birds and mammals. While our current AI models can only identify birds and bats, we plan to develop an AI model to recognize amphibians and mammals, similar to BirdNet. Amphibians are globally threatened, making their monitoring critical for understanding ecosystem health. Developing this model will require extensive training, but our recorders are already capturing amphibian vocalizations. Once the model is ready, we can analyze behavioral patterns and seasonal changes. However, detailed vertebrate activity data has highlighted a significant gap. We lack environmental context data, such as plant phenology. Phenological patterns are crucial for understanding the habitats in which these animals live. To address this, we plan to install automated phenological stations. This addition will help us assess the impact of climate change on the life cycles of both plants and animals. Over the next few years, we aim to gather detailed data on these interrelationships. We also plan to install temperature and humidity loggers, allowing us to monitor microclimatic conditions. So, what will this mean for biodiversity conservation? By combining data on animal activity with detailed information from phenological and microclimatic stations, we will gain a comprehensive understanding of how species interact with their ecosystems. We will also detect early signs of how climate change impacts both animal behavior and plant life cycles. This means we can take action sooner to protect vulnerable species. And finally, this holistic approach will help us manage habitats more effectively. We will be able to design conservation strategies that address the real needs of both wildlife and their environments, ensuring a healthier future for our biodiversity.
Alongside advanced monitoring, we are committed to engage younger generations. We maintain strong relationship with schools, universities, and local communities. Annually, we host over 3,000 student visitors and conduct workshops, open lessons, and seminars. We plan to develop interactive digital quests and eco educational modules focusing on biodiversity and conservation. These tools will make learning engaging and interactive, encouraging students to explore and to protect their nature surroundings. In addition, we actively share our educational content on social media. Using photos from our trap cameras and fieldworks, we create posts that teach about local biodiversity and nature conservation. This outreach helps raise awareness and foster a deeper connection between youth and nature.
В бурих жаб зверху за очима є така В-подібна смужка. Якщо знати, де вона має бути, як вона має виглядати, то ви її побачите. Також бурі жаби дуже часто, де барабанна перетинка, тут збоку, бачите, око, за оком є така барабанна перетинка, вони не мають такого вуха, як ми, вони мають.
Our efforts face significant challenges. The reserve borders Ukraine's largest military training ground, where field work is disrupted and electronic signals are often blocked for security reasons. This makes manual monitoring difficult. Automated devices, however, continue to operate reliably, ensuring continuous data collection even in these challenging conditions. Our project aims to modernize biodiversity monitoring, expand environmental education, and ensure reliable data collection. With your support, we can create a model for conservation that combines advanced technology and community involvement, inspiring the next generation to protect our planet. Together, we can make a lasting impact on biodiversity preservation.